I'm Anil Kumar, sharing with you a set of questions in this list of videos, which are going to help all the students who are starting with the course on calculus. You need to review a few topics before getting on with calculus, and all the videos in this list of videos are pertaining to the same. So I have from my side taken just one example from each topic. So each video is very important. Now here we have a very basic video on functions. So we'll basically review functions as we go along. The question here is, explain the difference and similarities between the graph of f of x equals to 5 to the power of x and g of x equals to x to the power of 5. So we are dealing with two basic functions, and we want to understand how are they similar and how are they different, right? That is what we need to understand. So what I'll do here is sketch both of them. I'd like you to pause the video and sketch these functions also, and then check with my solution. Now f of x is 5 to the power of x. What is this function? Can you tell me? So we are trying to understand what is f of x equals to 5 to the power of x. Now this function is basically an exponential function, right? So it will be always increasing and kind of like this. So this is the function f of x equals to 5 to the power of x. Now this point, if x is 0, then anything to the power of 0 is 1, and if x is 1, then okay, so let's take this point to be 5. So, and we'll consider this to be 1, right? So if x is 1, let's say, what is f to the power of 0? It is 5 to the power of 0, which is 1, and f of 1 will be 5 to the power of 1, which is 5. So these are critical points for this function. Can you tell me what is going to be f of minus 1? This value will be 1/5. Is it okay? So we just took few points to review the concepts about exponential function, right? Now let me sketch the other function, which is g of x equals to x to the power of 5. Now can you tell me how will this function look like? Well, this is a polynomial of degree 5, correct? So it will be kind of like this, like a cubic function, but flatter at 0, right? Because it has 5 roots at 0, right? So this is the function which is g of x. So this is g of x for us. Now here at 0 it is 0, and at x equals to 1 the value will be what? 1 to the power of anything is 1, right? And x equals to minus 1, the value is going to be minus 1 because the order is odd, right? So what we find here is that f of 0 is equals to 0. I should write g is g of 0. G of 1 is 1 to the power of anything is 1, and g of minus 1 is minus 1, right? So this is just to help you sketch the graph. Now the real question here is, explain differences and similarities between the graph of these functions. I'd like you to pause the video now and then explain similarities and differences, correct? So we'll write similarities, maybe differences here, okay, anything. So let's try to list at least two. Okay, 2 differences and 2 similarities. Can you help me write them? They look very different, right? It is very difficult to write similarities. But differences, well, you could write many differences in this particular case. For example, here, one of the differences could be 5 to the power of x is difference in range, right? So what you say here is f is always positive. Is that okay? Now this is not. So that gives us a difference in the range, correct? So what we see here is that the range of f of x is all real numbers where y is greater than 0. However, range of g of x is y belongs to real numbers. So as far as the range is concerned, these two functions are very different, correct? What else do you think? Differences. Well, one of the differences is that this function is concave down and concave up. The concavity changes, right? So we could write a difference as in terms of concavity. Now these terms are very important from calculus point of view, and therefore I'm using these terms. So we say that the exponential function f of x is, what is the concavity? It is always concave up, right? Is always concave up. All right. Whereas in g of x, its concavity changes at 0, right? It is concave down in this portion. So in this portion, it is kind of downwards. Do you see this kind of curve which is concave down? So this is called concave down, the shape of the curve. And here it is concave up, right? So that is the shape of the curve. So we'll stop at these two differences. These are critical differences. And behavior is another very critical difference. As x approaches, you could write here, as x approaches negative infinity, as x approaches negative infinity, what happens to y values, right? So in one case, y approaches 0, and in the other case, let me write now g, right? G approaches negative infinity, so that they are different. When you're approaching a value, in that case, we'll call this as a horizontal asymptote, right? So this function also has a horizontal asymptote. Perfect. So this function has horizontal asymptote, whereas there are no asymptotes for the other function. Correct. So that gives you many differences. Now let's talk about similarities. That's critical. How are they similar? That is what we have to figure out. Yes, how are they similar? Now, one of the similarities is you'll find that both the functions are, can you find their intervals for increasing and decreasing? What you really see is both the functions are actually increasing, right? So if you draw a tangent line, the slope is never negative. It is positive, 0, positive. Here it is always positive, right? So what we see here is both functions both have positive, non-negative slope, right? So what we see here is that the slope is never negative. Do you understand? Right? So basically you find that both functions are increasing since they do not have negative slope anywhere, right? So both are always increasing. So that is a huge similarity between these two, right? So if you draw a tangent line, it is never negative. Do you see that? So that is what I mean. And another similarity is about their domain. Both domains are x belongs to real number, right? They are continuous functions without any break, and their domain has no restrictions, right? So these are continuous functions without any break, smooth curves, and their domain is all real numbers. So these are two very good similarities between these two graphs. I hope that concept of comparing different types of functions is very clear from here. Let's move on and then explore some more functions. I'm Anil Kumar, You can always share and subscribe my videos and put some likes if you like. Thank you and all the best.